Now if I just start this application, this runs in my local, and the first thing that it does is it will do in the backend I'm calling an OCI session authenticate, which will authenticate my session. And since all the resources I'm using out of the OCI cloud itself, hence it requires you to authenticate your tenancy and everything from there. So once it opens the chat, it will first take you to the authentication page, where we will do a quick authentication. Yep, and your chatbot is ready to go. Okay, let's start. Now we need to go into this chatbot, or I built this chatbot on the basis that the user already knows a little bit about the database that they are trying to analyze or to query. A completely new user with much more generic natural language questions probably won't work really well in this scenario. But if you have some understanding of the database that you are trying to query, it will be giving you the best results. And you need to think as a little bit of data engineering background, at least basic SQLs, because this chat is also going to output SQL so that you can verify the SQL before actually running it. And that is actually important so that so have some confidence on this chat system, so that it is not running random SQLs and giving you an output that you are not confident of. I mean, you often keep on thinking, and I've even asked data engineers who wants to use a chatbot for their day-to-day use, that when the chatbot actually gives you an SQL as output before running the query and giving you the result, it actually builds better confidence on the chatbot. So that is how this chatbot system prompt even has been engineered in a way that it will give you the SQL, and it will ask for your confirmation, and once you have confirmed, it will run it and get you the data. So let's first have an overview of the database itself. Let's say there's all the tables, CDI. Yes, it proposes an action that it is going to use the retrieval tool for this, and yeah, we confirm. And it gives you a list of all the tables. And these details are actually all mapped in the domain knowledge that I use to create the vector store. So when it's retrieving out of the vector store, it also gives you these outputs as well. So let's try the first table itself. Let's say list all the columns. So imagine this as more of a use case where you do not use SQL tool like a SQL developer or dbeaver, but your chat itself is that SQL tool where you can converse, you can get all these details, and you can use it to create your SQLs and then get the output. So this is almost exactly that use case. So let's do a simple thing. We have room here, and I have annotated a few of them with the business use case, but not all of them. But of course, you can annotate all of them with your required and very descriptive business use cases, so that the LLM understands what you want to do, what your natural language question actually means, and create better SQL queries. So let's say I do a little bit complex, but overall no joins are required. So now this open placement state, there is a column for this one, and the business use case that I have annotated to it is that the open placement state actually comes from the open value itself, as well as from null, none, or empty values. So the expectation is that the LLM will handle all the use cases in the SQL based on this business use case annotation. So let's see what it does. And if it is not able to do that, okay, for some reason it's hallucinating and it thinks that it needs to find something from the hypervisor table, but yeah, let me fix that. Now the main reason this happens is that the base LLM that I am using for this chat is a free basic paid version, so it does not have that much processing capability as you would have in a paid version, or even better LLMs. But this is out of the free playground chatbot that you have, which I have used just for a POC. So yeah, it hallucinates enough, but somehow I have been able to fine tune it. But of course, if you are using better LLMs, it will obviously give you much better results. This also does good, but it needs some guidance from us, like, okay, it does not use a retrieval tool anymore, and it just goes ahead, gets the query out from whatever data it already has retrieved. And now you can see that the query is also fairly correct. So it has SSDI region and all the cases handled for placement state. So if placement state is null, if placement state is empty, and if placement state is open, all three actually does mean that the placement state is open, and the LLM actually understands that and included that in the query. So we are good to go. Final confirmation, you can just give yes from the query, and it will get you the output of the query in a table format. Okay, one thing that it has not done, I did put it in the system prompt, but this may cause an issue, is that it did not add a limit 10 at the bottom, and that may blow up the chat. I mean, either two things, that may blow up the chat, or sometimes if the token limit is too much. It did not, you need to beat this, but you have to define the query, right? So define the query and the expectation is that it will rewrite the query, add a limit of 10 to it, and order by. Yeah, it will order by, it will add a limit of 10, and then you can just easily yes run it, and it will run the query for you and give you the result again. And after that we will see that how to visualize this. So that is one more additional thing that has been added in this version of the chat. So some analytics, but the primary focus is on the SQL query generation. So yeah, you get the top 10 ordered by the unique host count, and all of the other things are preserved. It's in this region, placement state is open, you have group by, having, ordered by, everything looks good. Now you just say visualize this in a bar graph. Now right now my code only has 3 provisions. You have a bar, you have a pie chart, and you have line graph, but for counts usually we use bar graphs, right? So yeah, you have a bar graph, interactive bar graph, where you can see the count of each of them, and yeah, looks good, right? Now let's look a little bit behind the scenes on how the agent is actually working. So if I go back, yeah, this blew up because no limit was provided, but okay, no worries there. So okay, I'm not able to scroll any further, but the agent started somewhere out here. It first used the retrieval. It gave you the list of all the tables and then the list of all the columns over here, and it proposed this action, right? Hypervisors, you already saw that, which I said no to it. So the user corrected the previous proposed action and clarified that quotes table should be used. So it uses this chain of thought, and the format is very strict. So you have first coming in the question, and then the thought, then the action, and the action input, which basically is a tool, and whatever input goes into the tool. And at the very end you have the observation, based on which it should actually go back to another thought, or it will give you the final thought and the final answer. So in this case, once I have clarified that, it gave me the final answer as this is the proposed SQL. And once I confirmed it, it ran that query, it retrieved the data and got all the data. And after getting all the data, it will also, this tool is configured in such a way that it will also pass this data through a formatter that will format it into an HTML form, so that I can show this easily on the chat application. So that is how the tool is designed to work. But of course, if you are using this tool somewhere else, like maybe we will use this tool later on in an MCP server, of course we won't be using these features, because MCP features are supposed to be working in any agent, and it may or may not have an HTML capability. So yeah, right now for this chat I'm just converting this into this format so that I can view a good table in the chat window. The next thing is here the unique host per room. Okay, you get that. Your chain is finished. Okay, sometimes it hallucinates. So even after it has ended, and even without another additional question, it also gives you the same thing again, as you saw. I asked for refinement, but it gave me the same result. Some hallucinations are normal for this free version of the LLM, but I think we can live with that. The next thing which we did, okay, so one of these problems that you will see coming around is invalid format. So why does this happen? So the chain of thought is based on a format of thought, action, action, input, observation, and then back to thought, either back to thought or it will be a final output. But sometimes the LLM is not able to understand that the format that it is going ahead with is actually correct. It thinks that it's maybe an invalid format because there are scenario-based chain of thoughts. The chain is actually scenario-based and it's not the same chain every single time. It will either go back to a thought or it will give you a final output, right? So this, can you confirm, this actually should have been a final thought right? But it thinks that, okay, you're missing an action after that thought. But it eventually corrects itself and it does give you the final answer. So see, after that it corrects itself, it realizes that okay, this actually is the correct format, and it gives you the proposed result along with the question, can you confirm? So this kind of loops are very common in the React agent, and this is one of the reasons people have moved over to the most recent land graph structures, where all of these infinite loops of thought can be prevented. But anyway, for now this works good. One more thing that this chatbot is capable of is that it's very common to hit SQL run errors, right? So maybe it has proposed a wrong SQL and you are not aware of what are the correct columns. So you just give your confirmation that okay, yes, run this. But then it hits into an error. But what it does is that it does not throw an error. It will analyze the error. So what I'm doing is I'm passing this error through the LLM itself, and then I'm asking the LLM to correct the last SQL. So what it does is it analyzes the error, whatever error has happened, and it goes back to the its own scratchpad and it fixes it, whatever is the issue. And it will then propose the fix to the user. Okay, one of two things: it will either propose the fix to the user, or it will fix it and run it itself. And the fix usually always, almost like 95% of the time, the fixes work. And after it has fixed its own query, it's a self-fixing SQL basically, it retrieves the data and gives me the output. Yeah, looks good. And then finally, when I ask it to visualize this, so I'm not building a graph at the back end. That is, in my opinion, a bad way to actually generate a graph, because if you generate a graph at the back end, you send it all the way to the front end. It's payload intensive. What I could have also done is generate it in the back end, store it in cloud, and give the URL of the cloud as payload back to the chat application, where at the front end application can just access the URL and show it to you. That way, that also works. But for now, I have not done such an advanced thing. I have only taken the data from the last query and turned it into a chart configuration. So this is also a deterministic function. This is not done by the AI. A determination function built as a tool. And what I do is I just send this chart configuration back to the front end, and in the front end I use some tools to render the chart based on this configuration. Of course, I annotate it with tags so that I know that it is the chart data, and I have to take out this data for a different kind of analysis than all the other elements in the front end. And this is how the chat goes. Yeah, thank you for watching, and if you have any questions, you can definitely ask it in the Medium channel that is linked to this video. Thank you.